Alright, this is 3.4 PowerPoint electron configuration. So basically the order of electrons that fill up in their orbitals. So to represent a electron configuration, you talk about what energy level they're in, which is that first number, which orbital they're in this case S, and how many electrons in the S orbital or whatever subshell they're in this case 1 electron. So for helium, it has 2 electrons, it will fill the outer shell of the 1s, so it's 1s2. 2 represents the number of electrons. Lithium will move on to the second energy level after the filled helium and have a 2s1 because of the 1 electron. 1 plus 2 is 3. General questions would use the 1s notation to give the electron configuration. So in this table you can see there's a pattern following hydrogen through argon. You can see hydrogen's 1s1, helium's 1s2, then you get into the second energy level with lithium being 2s1, beryllium 2s2, and so forth, and it fills up in a pattern. All the way down to argon, which has 18 electrons, so it has 1s2 is 2, 2s2 is 4, p is 6, s is 2, that is 12, plus another 6 is 18. And when you get to the transition metals, or sometimes you see argon as a shortcut, represents all the electron configuration up to argon, and then it goes into the 4s1, 4s2. Then you get in the transition metals, the D block. A couple things to notice: chromium and copper are different. In chromium, the 3d5 actually gets filled up before the 4s. So basically 1 electron gets moved into the D block and you're left with the 4s1. Copper is the same thing. Once the D block gets filled up, it takes away from the 4s, so the 4s is not completely filled. Alright, so provide the electron configuration of the atoms with the following atomic numbers. So that means the same same electrons: 16, 9, and 20. So you need to get 16 electrons, 9 electrons, and 20 electrons. So you have 1s2, 2s2, 2p6, 3s2, and 3p4. That represents 16 electrons. And then for B, 1s2, 2s2, 2p5 represents 9, which would be fluorine. 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2 represents 20 electrons, which would be calcium. So sometimes you see the shortcut for argon represents the full outer shell of the 3p. So to shortcut it up, you use parentheses or brackets argon 4s1 to represent potassium. Remember, once you get to the 4th energy level, 4s fills up before you get to the D block, and then you fill up the D block, except chromium and copper. As you can see here, again, the 4s does not get filled in chromium, and in copper as well, the 4s does not get filled up, but the D10 does. Once you get past the D block, so the D is filled, it can only hold 10 electrons, you go into the 4p. So you can see gallium is 4p1, and bromine's 4p5, krypton 4p6. Provide the electron configuration for the following elements: vanadium, copper, selenium. You would see those answers. Vanadium would go 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, and 4s2. So notice the 4s2 gets filled first, but you write the D before the 4 because of the energy level. Copper is that one lone or two lone exceptions. You gotta remember that the D gets filled up first, then the 4s has a 1, and selenium follows along all the way to the 4p4. So you can see here you have the S block in the alkali earth metals, the D block is your transition metals, and then your P block are from boron to your noble gases. Alright, here's your homework question. What element has the electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, and 5p6? And what is the element for the electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1? Alright, filling the orbitals. So this helps a lot with understanding the ionization energy and the anomalies sometimes occurs. So in an orbital you can only hold 2 electrons. The 2p member has an x, a y, and a z orbital. Now you can see that the arrows are one up, one down. That means they are opposite spins. Electrons are negative, so they repel each other. So one's going in an upward spin and one's going in a downward spin in the orbital. So you fill up just like you do in the orbital. This is more of a diagram. So you fill it 1s first, then you go to 2s, then 2p. So in this example you have boron because it's 5 electrons. So for carbon you have a 1s2, a 2s2, and a 2p2. So what do you do with that extra electron? So first 1s fills up and down. Then your 2s fills up. So that gives you 4 electrons. Now for the p orbital, you always have to go in a positive spin first. So the 2p in the x direction fills up first, goes up, and then you have one in the 2py. So everything goes up first, and then you start filling up the other orbitals. That's the reason. The reason why is because they want to be as far away as possible. There's no particular order. If it's x, y, z, it's just alphabetical as it did. But you gotta remember to fill in the upwards first, then you go back and fill in the downward. So for nitrogen, you have the 1s up and down, the 2s opposite spins, then you have 1 in the 2px, 1 in the 2py, and then 1 in the 2pz. So it's all filled up with the positive spin. Now for oxygen, you have the 1s, 2s filled up. You have the upward spin in px, upward spin in py, upward spin in pz. Then you go back to your px, and then you start your downward spin. So the reason why we do this is because it helps identify when you do ionization energy. It helps identify why something requires more energy than the other. Alright, lastly is the configuration of ions. So pretty simple, you're either going to add electrons or take away electrons. So for sodium, the originally is 1s2, 2s2, 2p6, and a 3s1. If you take away an electron, you get rid of the 3s, and you're just left with the 1s2, 2s2, and a 2p6. Sulfur, on the other hand, it gains 2 electrons. So instead of a 3p4, it becomes 3p6. So when you're dealing with filling up the electrons, the 4s always fills up before the 3d, but the 4s loses their electrons first. And the reason why is because of the size. 3d is more quite tightly packed than the 4s. So the 4s actually will lose its electrons first. So for here you have titanium. configuration, see that the 4s gets filled up first, and then you have the 3d with only 2 electrons. But if it loses 2 electrons, that means the 4s will lose those electrons, and you're left with the 3d2. So the 4s2 is completely gone. Well, the electrons are gone, not the orbital. Alright, so write the configurations for the following ions. You have aluminum 3+, that means it's going to lose 3. Oxygen 2- gains 2. Iron 3+ loses 3. Copper 2+ loses 2. And copper 1+ loses 1. So here is your answers. So make sure you have this correct, and we will continue this in class. If you have any questions,